Hello everyone, my name is Sarang Borude and I want to welcome you to the second part of this tutorial. So if you have not seen the first part of this tutorial where we created world anchors and basically used them to create these entities that control lights, I would really encourage you to please go and see that tutorial first, because everything we are talking about right now in this part is going to depend on that one. So this part is basically a continuation of that one, where we are going to cover how we can control the lights by presenting a UI besides the sphere entity which controls the light. Let's jump into it. Let us first start with the demo of what we are going to do here. So here you can see that I can press and hold at a light, and after a delay a UI appears to the right of the light, and now I can use this color picker to change the color of the light. I can do the same thing to the other light, and you can see when I kind of go from one light to the other light, the UI fades out on one light and gracefully appears on the other light. So there is some animation that is happening over here that we'll cover as well. So let's jump into it. So as an overview of what has changed since the previous one is there are very minor changes in the app model. I can tell you right now what the changes are. So in the app model, what I've done is added this boolean that controls when the light control UI is being shown, and then I have also added this callback of on light control UI presented. This is using the app model as a middleman for communicating between two views. So those are the changes in the app model. Then most of the work we are going to do is handling the gestures here in immersive view. So we'll look into this and then creating the view as an attachment, and then we'll also look at like how the UI was made and how the color wheel was made. That's all that we are going to cover in this UI. We are not going to talk too much about ARKit and world anchors in this tutorial. So if you're curious, please watch the previous one because that covers a lot in detail. Let's see how all of these things are working. So in our reality view, in our immersive view, what we are doing is we are adding an attachment for our light color control view over here. And then once we have added this attachment over here in the make closure, we are getting the entity for the attachment. And then once we get the entity, we are doing the same thing that we did for our light config UI. We are setting a opacity component on it and setting its opacity to 0. On the app model as well, we are simply adding the light color control UI, and we are saving this entity over there so we can manipulate it however we want. So again, you can see if we go to the definition here, just the way we did it for light config UI, we're doing the same thing for light color control UI. We are saving the entity over here. So once we have done that, we'll simply add it to our content, and it's a hidden entity added to our content. So again, I want to say this. I have also mentioned this in the previous tutorial, but it's very important detail, because if you have an opacity component on any entity and if you set its opacity to 0, it does not accept any input events. So no spatial tap gestures, no drag gestures, nothing. This is a benefit over here, but can really trip people if they don't really know about it. It's actually a good feature by design, because you don't want hidden UI layers sort of accepting input and not letting the input pass to like whatever is behind them. Just something to keep in mind. So what we are doing here is we are looking for this particular show light control UI toggle, and whenever that is set to true, we are presenting the light color control UI entity in front of the user to the right of the sphere that controls the light. Okay, so you can see that for the edit mode UI we did the exact same thing, so there is nothing new about it. The way we are presenting this entity here is basically detecting a drag gesture whenever we are not editing our light configuration. So let's look at this drag gesture that we are talking about. So in the drag gesture, that is targeted to any entity that has a light control component. So previously when we were editing the lighting setup, we were simply using the drag gesture to set the light control entities or the spheres on the lights. So here what we are going to do is when we are not editing the light setup. We want to save a timestamp, which is the start time, and we'll start a timer that is activated whenever you start doing this particular gesture. And then if the duration, which is the time since the user has started pressing, has passed 0.25 seconds and you have not previously triggered this, we'll trigger the long press gesture. And then when the long press gesture is triggered, we'll do the same things. From our entity, we'll get our light control component and we'll set it as our currently selected component. And then we'll also set our selected light control entity from the detected gesture, and then we'll call this function handle long tap gesture when not editing. So we'll look into this function in a bit, but we also need to handle whenever this gesture ends. So you can see that I'm resetting the long press start time, long press timer active, and long press triggered. So I can reuse this gesture on other entities as well. So let's take a look at this long tap gesture when not editing function. So here I'm simply in the app model setting the currently selected type from the currently selected component over here, and all I'm doing is setting this boolean here, which is show light control UI to true. One more thing I wanted to talk to you about, that this gesture is kind of interesting because see, we are enabling the long press trigger to true when the value of the drag gesture is just being changed. That means when the user has already pinched and not released, and after a certain time passes, that's exactly when we will trigger. So we don't want the user to open the fingers for the UI to trigger. We want them to keep holding, and after a certain threshold we sort of automatically present the UI, and I think this works way better. I did write the code to handle the long press gesture over here, and I set its duration to 0.5 seconds, but it did not work reliably. So here in this video you can see that I'm using a long press gesture with a minimum duration of 0.5. It only works a few of the times. And then another problem with this is that the user has to press and then release the tap gesture for it to activate, and that becomes a problem. So that's why I'm sort of relying on the drag gesture. In the drag gesture, the user can keep holding, and after a certain time duration, it basically triggers the presenting of the UI. The only problem with this hack is that sometimes if the user's hand is super stationary and not moving when doing the spatial drag gesture, the spatial drag gesture doesn't get triggered, and due to that the UI doesn't get presented. But if you subtly move your hand, like subtly drag, then the UI gets presented. So yes, it's a workaround, it's basically a hack. Ideally we kind of want something like a long press hold gesture, something like that, which will allow us to present the UI more gracefully. That doesn't exist today, hopefully in the future, but this is a good workaround that can give you good results. Another way to do this is basically in your app, you can simply create a separate mode, and when your app is in this separate mode, you can do a spatial tap gesture, and when you do a spatial tap gesture, you basically enable the UI. I have played around with this. I don't necessarily like it because it kind of takes away the magic of just like looking and pinching at the light and turning it on and off. I felt that was more magical. So now if you add a separate mode that the user has to put the app in, and then the user kind of pinches and presents the UI, and now you can control the app with the UI, it really is not that interesting as just like looking and pinching and enabling and disabling the light. So this is the code that actually presents the UI. What will happen here is, now when we change the toggle to true, we'll call the position UI entity to face the user with animation, and we pass it light color control UI entity. So let's again look at this function. We have looked at it in the previous tutorial. In the position UI entity to face the user with animation, that's quite a mouthful, but what we are simply doing here is we are creating two actions. Both of them are from to by actions, and they are for tweaking a float value. So the show action tweaks the float value to 1 and the hide action tweaks the float value to 0. We have a timing function on both of them. They both use ease out. And using this two actions, we are basically creating a show animation and a hide animation, and we are setting the duration of it to 0.25 seconds. And the bind target is going to be the opacity property. So you can see that we are basically affecting the opacity property on the opacity component of this particular UI entity. So here again we are doing the same thing. We are basically getting the opacity component on the entity and we are checking if the opacity value is 0. If the opacity value is 1, that means the entity is already visible. So first we hide it. So first we play a hide animation. We wait for 0.25 seconds so that the hide animation finishes. Once that finishes, we basically play the show animation. If it's not visible, then we are simply presenting by calling the play animation on our entity by doing the show animation. Okay, there is a slight difference here compared to our previous tutorial, that I have this one line of code which is basically a callback on light control UI presented from the app model. What this is doing is basically facilitating communication between the immersive view and our light color control view. What happens is whenever we present this view to the user, what we want to do is we want to get the status of the light using an API call and show the correct state of our light on the light color control view. So whenever our immersive view opens or presents this view to the user, we go to the light control view, and what we do here is we refresh its state by doing an API call. So that's exactly what this callback is doing over here. So you have again seen the position UI entity to face user function. I'll just walk you through one more time. The goal here is to basically present the UI to the right of our sphere entity, and again make sure that when the UI is presented, it faces the user. The way we do this is first by getting the device transform by using the app model's getCurrentDeviceTransform function. Then from it, we extract the user's position. Then we calculate a direction vector by subtracting the user's position from the light position. This vector is pointing from the light to our user, and then we do a cross product between the positive y-axis and this direction vector, and the cross product will basically give us a vector pointing to the right of our sphere entity. Then we calculate an offset by multiplying the right vector by 0.3, which is basically 0.3 meters to the right, and then simply add this offset to our entity's position. Now that we have positioned the light color control view's entity, we also want it to face the user. And we can do that by calculating an angle by using the a-tan2 function by passing it the directions x and z coordinates, which will basically give us a rotation along the y-axis. Then we create a quaternion from it, and once we've created the quaternion, we assign that to the orientation of the entity. Now let's take a look at the light color control view and see how we can use it to control the colors of our light. So we have a V-stack, and in that V-stack first we have an edge stack with a spacer and a button. This button is the close button that closes the UI, and it makes the UI disappear after an animation. Then I have a toggle over here that is bound with the isLightOn state variable, and then I am using this color wheel, and below the color wheel I am also using a slider that controls the brightness of the light. So that's pretty much for the UI. We are handling the unchanged events of these three views, and whenever the views change, we basically use our Hue control manager to send values to our lights. So here you can see that I am subscribing to this particular callback over here. So what I'm doing is I'm using this callback so that whenever this on light control UI presented gets called, I'm calling this function get light or group status and update UI, which means whenever this UI gets presented, I make an API call to Philips Hue hub to get the status of the light. So let's look at the code here. So here you can see that I'm simply making an API call here, and once I get the API call, I'm basically pulling in all the values, and I am setting it to the is light on, the brightness, and the color values over here. And then so this is basically the callback of what should happen after I get the result, and this is the actual call for get light status. So what happens is, if the component is of a type light, the Hue control manager will call get light status. If the component type is of a group, Hue control manager we can call get group status for a particular component name. And then when we receive the completion, we basically call update state from result, which is basically this guy right here. So this is a completion handler, and in this completion handler we check what state we are getting for the light. So is it on or is it off? What's the brightness value? What is the color value? And we are getting the hue, saturation, and brightness value from here, and we are converting it to a CG float, and then we are basically saving it in color. So that's basically what this function does. It sets the initial values whenever the view is presented to the user. That's all. Let's look at the main thing, which is like, how does this view actually manipulate the colors and the brightness and everything else. So we can see that on our color picker, what we are doing is, whenever the color changes, what we are doing here is converting the color, which is a UI color that we get from dragging on this color picker. So we have to convert this UI color into CG floats and send it to hue. So from UI color we can use this helper function that gets us the hue, saturation, and brightness values, and we have to convert it to whatever Hue expects, like the Philips Hue API. So the Philips Hue API, the hue values kind of go from 0 to 65,535. The saturation goes from 0 to 254, and the brightness values go from 0 to 254. So we have to convert the values from UI color to these numbers, and then this is kind of important. If the last color update was less than 0.25 seconds, don't do anything, just return. So what this does is, we only send 4 updates every second for changing the color values, and that limits how many API calls we do every second, and this becomes performant. If you don't do this, and if you just directly keep sending the values, you'll probably see that these kind of calls get piled up on top of each other, and you will see that the light will change very slowly because it's processing the previous commands you have sent. So now what we are doing is checking if so we have done this previously for turning the light on and off, but here what we are doing is, if it's a light, we are simply calling control light, and the control light function, we are passing the name of the light we should control, which we can get from the light control component. And here in this state dictionary, we are simply passing the hue value, which is the scaled view, saturation, we set the scaled saturation, and then the brightness, which is the scaled brightness, and we simply make the API call, and whenever the API call happens, the light changes color. Same thing with the group over here. Now I think we are doing something very similar for brightness again. So we are doing the same thing. We are computing the brightness value and scaling it, and we are again calling the control light and the control group function over here, and simply setting the state or the action in case of a group with the brightness value. Same thing with the toggle. Whenever the value of is light on, which is a boolean, changes, we are doing the same thing. We are making the API call to Philips Hue, and we are setting the on parameter for the light to whatever the new value is, whether it's true or false. I think the one interesting component here to look at in this particular view is the color picker itself, or the color wheel. So you can see how the color wheel was implemented. The color wheel was implemented, it's very simple. It's a geometry reader, and then it's a Z stack with an angular gradient, and we are creating an angular gradient by setting the colors from 0 to 1 and changing the value by 0.1. So we are creating the color values by passing a hue, saturation, and brightness. Once we created this angular gradient, we are also creating a radial gradient to fade to white in the center. So we reduce the saturation as we go to the center, so the color kind of becomes white in the center. Then we mask it with a shape of a circle, so it's a perfect wheel. And we also create a circle here with a border. And this circle is a drag handle to show the user which color the user is picking. So you kind of have this position view modifier over here, and as the user is sort of dragging on this view, you set the position of this circle inside the color wheel to let the user know which color they are picking. Since we are changing the position of it, that means there needs to be a gesture. So we are using a drag gesture here, and in this drag gesture, in the onChanged, we are getting the value of the X and Y position and subtract the radius from it, and then we are measuring an angle using again our a_tan2 function over here. So once we get the angle, we can calculate the value of the hue by converting the angle between 0 and 1, and we get the saturation by getting the distance from the center. Okay, so again a little bit of math, but simply using distance formula, and then we assign the current hue, current saturation, and then return it and create the color value for whatever the position the small circle is in the color wheel. And we set the hue, saturation, brightness and alpha values to 0 whenever the view is presented for the first time. And that is how the color wheel is actually implemented. The one tricky thing I had to figure out is converting the coordinates from like Cartesian to radial coordinates. That was basically me experimenting, playing with values. So here's how we create the color wheel. Okay guys, so that brings us to the end of the second part of this tutorial. In this part, we looked at how we can create SwiftUI views as an attachment that we can then attach to our entity to control the color of the lights. In the next part, we are going to make things a little more interesting. We are going to create a slingshot mechanic where we are using ARKit to detect our hands, and then whenever the user does a peace gesture, we put a projectile spear in the middle of these two fingers, and whenever the user pulls back and releases this projectile, and when the projectile collides with the light control entities, we'll be able to change the color of the lights. It's going to be very fun, so please make sure you subscribe to the channel, and please don't forget to like this video if you liked it. Thank you so much. I'll see you in the next one. Bye bye.